but we will discuss the hydrodynamics part of the fluid. But before studying hydrodynamics, let us discuss about hydrostatics. Hydrostatics. Hydrostatics is that branch of physics. Hydro means water, but here for any kind of fluid. And static means rest. Static means S-T-A-T-I-C. Static means rest. So this is the branch of physics. This is the branch of physics which deals with the study of properties of fluid. Properties of fluid at rest. When the fluid are not moving, when they are at rest. When the fluid is at rest. But a fluid rest में है, fluid move नहीं कर रहा, तब उसके साथ क्या क्या प्रॉपर्टी है that we will discuss in this part. So first part is pressure applied by any fluid. First one is pressure applied by fluid. Pressure applied by any fluid. Applied by any fluid. This is the force acting on per unit area. This is the force. What is pressure? Force acting on per unit area. Per unit area. What is pressure? Pressure is force acting on per unit area. Unit of pressure is Pascal. Unit of pressure is Pascal. And you know unit of force is Newton. What is the unit of area? Meter square. So if 1 Newton of force will act on how much area? 1 Newton of force will act over how much area? 1 meter into 1 meter. That is 1 meter of area. So then the pressure will be said to be 1 Pascal. That the pressure is said to be 1 Pascal. बेटा जब भी किसी सरफेस एरिया के ऊपर, सरफेस एरिया का डायमेंशन क्या है? 1 मीटर लॉन्ग, 1 मीटर शॉर्ट. इस पर आपने कितना फोर्स लगाया? 1 न्यूटन. अगर आपने 1 मीटर स्क्वायर एरिया पर 1 न्यूटन का फोर्स लगाया, सरफेस के परपेंडिकुलर आपको फोर्स लगाना है, तो वो प्रेशर लगेगा. प्रेशर कितना लगाया आपने? कितना लगाया इस पर प्रेशर? 1 पास्कल. बेटा एटमॉस्फेयर प्रेशर का एक और यूनिट होता है एटमॉस्फेयर. हमारा जो वायुमंडल का घेरा है पृथ्वी के चारों, दैट इज एटमॉस्फेयर. बिकॉज ऑफ ग्रेविटेशनल पुल, दिस gaseous molecule keeps on striking the earth. And on sea level, if you see how much amount of this force applied by the atmospheric gases on how much area? 1 meter square area. This is called 1 atmosphere. And this 1 atmosphere is equals to 1.01 into 10 to the power 5, यानी कि 1 lakh Pascal. This is the pressure applied by 1 lakh Newton, around 1 lakh Newton, 1.09 into 10 to the power 5 Pascal. This is the amount of force applied by the atmospheric gases on Earth's surface over how much area? 1 meter square area. Now, so let us see how we can determine the pressure applied by any fluid. So let us see if this is a container and this container is filled with a fluid. If we are talking about any point at a depth d, or H below the free surface. Now see here, beta. If you take this cross section area, this this portion, let this cross section area is there. If you want to find the pressure applied by the fluid at this point, then we have to take all the fluids above this horizontal level. This whole fluid, will be acted by the gravity force. बेटा अगर हम कंटेनर में फ्लूइड भरा हुआ है और हम इसके अंदर यहाँ भी बात कर सकते हैं, यहाँ भी कहीं एक जगह हमने इस पॉइंट को दिया, तो इस पॉइंट पर प्रेशर क्या लगेगा, तो हम देखेंगे इस पॉइंट से ऊपर जो भी पानी है, जो भी फ्लूइड है, वो ग्रेविटी के कारण तो नीचे आना चाहेगा, जिसे वेट फोर्स कहते हैं, एबिलिटी। तो ये जो ऊपर का पानी का वेट है, what is the weight? Weight is equals to mass into gravity. What is the mass of this portion? This portion, due to weight, it wants to exert force over this area. What is the area of this portion? Area. Because this is cylindrical portion. This is beaker is in the form of cylinder. So cylinder has some area pi r square. This area is pi r square. How much force is acting? This force is equals to mass of this portion into G. Upon acting on how much area? This is weight. Mass into G is the weight force applied by which portion? If we are considering the pressure, then is spontaneous. Now how much fluid above it is? H. And what is the mass of this fluid is? You know, mass is equal to volume into density. If rho is the density of the fluid, what is this density of fluid? Now you know, mass is equal to volume. What is the volume of this whole fluid? That is represented by shaded portion. Volume is equal to pi r square A into H. Pi r square H. Pi r square is the cross section area or this cylindrical portion, cross section area, circular portion of this cylinder. That is A. Pi r square H. Volume. Volume into density, mass of the fluid. That is fluid. And this mass is attracted by the gravity. And because of this weight force, this whole fluid will exert force over this surface. Mass is equals to volume into density, mass into G, weight acting on per unit area. Force acting on per unit, because weight is a force. Area cancel out, but a force acting on per unit area cancel out. And that's why the pressure formula for the pressure will be how much? H rho G. From here we conclude that pressure depends upon the height of the fluid above that point. If you want to find the pressure at this point, then this point is only this height. So when we are moving more and more deeper into the fluid, more volume above it will exert force. So if we are taking this point, then we will take all the fluid above this point. This whole fluid, due to their weight force, will exert force over this cross-section area, over this surface area. And the force acting on per unit surface area, that is known as the pressure. So formula for pressure is H rho G. Rho is the density of the fluid. What is the formula for pressure? H rho G. So more be the height of the fluid in the column, more will be the pressure applied by the fluid. Now, let us see what is Pascal law. But the next topic we will discuss is Pascal law. Pascal law. According to this law, if this is a fluid which is completely enclosed, this is enclosed, fluid is filled inside. Now, if from here you apply excess pressure, Excess means from external you are pressing this piston. This piston is in piston means just like have you seen pitchkari in holy or seer when fluid is filled here from this end when we are pressing, then what will have through this piston the pressure is given to fluid and this fluid will eject out through the nozzle. So this part is called piston through which we exert pressure over the fluid. Now you see it. Oh, through the piston. If you are, and this fluid is what type of fluid? This is incompressible fluid. Incompressible fluid. ये fluid जो दबे रहे fluid. Now, if you are exerting any external pressure from outside, then this pressure P is excess pressure is equally distributed. But see here, अगर आप यहाँ पिस्टन के थ्रू इस फ्लूइड पर प्रेशर लगाएंगे एक्सेस प्रेशर P, तो वो प्रेशर यहाँ भी पहुंचेगा, यहाँ भी पहुंचेगा, यहाँ भी पहुंचेगा, सरफेस के हमेशा परपेंडिकुलर पहुंचेगा और प्रेशर लगाएगा। वो एक्सेस प्रेशर अगर आपने यहाँ 50 पास्कल एक्सेस लगाया तो ये 50 पास्कल यहाँ भी लगेगा, यहाँ भी लगेगा, यहाँ भी लगेगा, यहाँ भी, सब जगह इस वाल पर वो क्या करेगा बेटा, पुश करेगा। दिस इज व्हाट पास्कल लॉ। हाँ देखिए बेटा, तो when we are exerting, what is Pascal law? See here, this is an enclosed fluid. What type of fluid? Enclosed. That is, ये फ्लूइड क्या है बेटा, एक बंद कंटेनर के अंदर है और कैसा फ्लूइड है, जो दबे नहीं, इनकम्प्रेसिबल फ्लूइड। तो बाहर से अगर एक्सेस प्रेशर लगाएंगे, एक्सेस प्रेशर, तो ये प्रेशर क्या होगा बेटा, फ्लूइड के जरिए, फ्लूइड के थ्रू ये सब जगह फ्लूइड में पहुंच जाएगा एक्सेस प्रेशर, यही पास करना, और जरा सा भी प्रेशर का लॉस कहीं भी नहीं होगा। यानी कि बाहर से अगर हमने एक्सेस प्रेशर लगाया फ्लूइड पर, तो फ्लूइड के जरिए अगर हम लोग ये प्रेशर दूर कहीं भेजना चाहते तो ये प्रेशर पहुंच जाएगा, लेकिन एक जरा सा भी प्रेशर का लॉस नहीं होगा। इट मीन्स थ्रू द फ्लूइड वी कैन ट्रांसमिट प्रेशर फ्रॉम वन पॉइंट टू अनदर पॉइंट। इस पॉइंट पर प्रेशर एक्सर्ट किए बेटा, फ्लूइड के जरिए ये प्रेशर यहां दूर पहुंच जाएगा बिना किसी लॉस के। इसे ही पास्कल लॉ कहते हैं। तो व्हाट इज पास्कल लॉ? अकॉर्डिंग टू पास्कल लॉ, according to Pascal law, if any excess pressure according to Pascal law, if any excess pressure, if any excess pressure is given to any enclosed fluid, enclosed means the fluid that is closed zone, बंद हो बेटा, that is enclosed fluid, then this pressure is transmitted to every portion of the fluid, to every portion of fluid without any loss, without any loss. This is known as Pascal law. This is known as Pascal. What is the application? Application of Pascal law is hydraulic brakes. What hydraulic brakes or hydraulic lift? hydraulic lift. But I see here, you might have seen that uh, there are many lift are made up of that can lift even of several tons of mass. It can lift. So similarly, hydraulic lift can raise or it can lift a very heavy mass. And what is the basic mechanism of working of that lift? बेटा जैसे कि मानिए कि थोड़ा सा बड़ा सामान है उसे आप लिफ्ट कर सकते हो लेकिन एक बहुत हैवी सामान है if a block is there which is very heavy but it is not easy to lift that very huge block. For example, a truck is containing a mass of several quintals or even in tons, and that can be easily lifted up by those kind of piston, those kind of lift. Hydraulic lift में क्या होता है बेटा? Basically, it contains fluids that is enclosed inside this chamber. But इसमें characteristics क्या होता है? It contains two arms. It contains two arms. Here piston is there. Here piston is there. One which have larger cross section area. Larger cross section area. Cross section area. Capital. And one arm have a smaller cross section area. Smaller cross section area. But here fluid is filled inside this chamber. Here fluids are filled. Their fluid are filled. बेटा इसमें फ्लूइड भरे होते हैं और स्मॉल क्रॉस सेक्शन. So this is called effort arm. The arm which have a smaller cross section area is called effort arm. E-F-F-O-R-T. Effort arm. And this is known as load arm. Load arm. But I see here, if we want to lift a truck, this is what? This is truck. ये ट्रक है बेटा. इस ट्रक को आप लिफ्ट करना चाहते हो इस पर ऊपर की ओर. Then what you have to do, you have to exert a force. This is effort arm, so you will apply here force. Applied force. And this is the area. So force upon area is a pressure. Whatever be the pressure you given here, this reaches here, it moves to every portion, and from here pressure P2 is given here on this piston in upward direction. So through the fluid, the pressure reaches here, and since this is the rigid valve, so valve will not move, but this piston is movable. So through the fluid, it will exert force on the piston in upward direction. So it will lift up this truck, heavy truck in upward direction. Here, this is upward arm, this is lower arm. Now, whatever be the pressure you applied on the effort arm will reaches to load arm. So what is the principle behind it? Is Pascal law. So pressure applied at, what is the basic principle? Pressure applied at effort arm. What is the pressure applied at effort arm? P1. P1 is the pressure applied. at F1. And this pressure reaches to load R through the fluid. If pressure applied at effort R is equals to pressure reaches at pressure transmitted to load R. What is this pressure? P2. And this pressure P1 is equals to P2. What is the difference here? The cross section area of this effort R means बेटा यहाँ फोर्स लगाएंगे और यहाँ फोर्स आप गेन पाएंगे. Here the cross section area बहुत छोटा है, तो बट प्रेशर क्या होगा बेटा? सेम. यहाँ जो प्रेशर लगेगा वही यहाँ पहुंचेगा. प्रेशर इज इक्वल टू फोर्स, अप्लाइड फोर्स upon area, very small. What is this here? What is the weight that is to be pressure at P? Pressure is equal to force. What is the force upward? This is equals to weight of the truck. By what is the cross section area? So we can say that we can say the output force. Force output is equals to, we can write force output is equals to force applied into capital M move here A. बेटा A यहाँ चलाएगा और ये नीचे. अब ये देखिए बेटा, ये एरिया जितना टाइम्स इसका बड़ा हुआ, ये छोटा से छोटा रखते हैं और ये इसका कई टाइम्स बड़ा. अगर ये 100 टाइम्स बड़ा हो गया लोड आपकी क्रॉस सेक्शन एरिया पिस्टन के एरिया बड़ा हो गया तो 100 टाइम्स 100 अपॉन 1 मीटर स्क्वायर. ये 1 मीटर स्क्वायर एरिया और 100 मीटर स्क्वायर एरिया क्रॉस सेक्शन, तो ये क्या होगा 100 अपॉन 1, दैट इज 100 टाइम्स ज्यादा फोर्स मिलेगा हमें. आउटपुट फोर्स क्या मिलेगा? 100 टाइम्स. तो फोर्स अप्लाइड इनटू व्हाट इज क्रॉस सेक्शन एरिया ऑफ द लोड आर्म upon cross section area of the effort arm. Cross section area of the effort arm. So we can get large output force. What is the purpose of this lift? By applying lesser amount of force, we can lift up very large weight. So here force gain is very large. It is what is the applied force? Fa, and it is how much time more? It is equals to the ratio of the cross section area of the piston of the load arm upon area of the cross section of the effort arm. So if this ratio is 200 times, then 200 times more we will get the output force. That is around 200 times more weight we can lift by applying a certain amount of force. So with the help of this Pascal law, we can increase the force to several times. And this principle is basically used to make lift for lifting very heavy mass. But आपको